Hello, everyone, and welcome to the webinar. We will start in just a few moments from now. Thank you. Hello, everyone, and welcome to today's webinar. Today's webinar will be the first part in a three-part series on Swiss type part programming, and this will be given again by Marina. This is, of course, being recorded and will be available later on. So without further ado, we'll put this over to Marina. So Marina, I will make you now the presenter, and you can show your screen and start.
Okay, thank you, Sydney. Just want to check if you can see my screen.
Yes, I can. Go ahead.
Okay, very good. Hello and welcome to the webinar. Today I will start a series of Swiss type webinars. 2 sessions will cover CAM part creation from scratch, and during the last session I will show some advanced Swiss type programming process. I will start today's webinar from machine review, which I'm gonna use today. Here on a picture, you can see a Citizen L32 machine. The current model, which will be used today, is equipped with a 6-position OD tool holder. It has 3 radial tools and the B-axis station with 8 tools. 4 tools are used for the machining on the main spindle, and 4 tools for the machining on the back spindle, and B-axis is limited from 0 to 90 degrees. All the tools are located on a device which we call gang, and gang can move in X, it's a vertical direction, and Y direction. The next tool set is for the back spindle. We're gonna use it on the next webinar. Today I just show you what we have here. Here we have 2 rows of the tools. Each tool position can both be for milling and for the turning. It is driven, and if it's gonna be driving or not depends on a tool holder. For example, here you can see the tool holder for the turning operations, and there are tools. This is the milling tool, for example. It is used for the milling operation, and if it's gonna be driving or not depends on a tool holder. Also, these tool blocks move in Y direction on the second channel. The last tool set is not visible here, and it's a back spindle tools. They are used for the deep drilling on a main spindle, and these tools are located near the back spindle. We will review them during the last 3rd session. Now I'm gonna to consider today's part. It's a like a standard solid CAM part. Maybe you seen it previously in our sessions. It is very nice to show different examples of programming, because this part has both drilling, turn drill, some drills on a face, on a radial direction, and inclined elements. We're gonna use B-axis today, and it is the dimension of the part. The diameter is 25.4 millimeters, and the length of the part, it's important thing, it's 45 millimeters long. And we will need both spindles to cut this part. I'm going to start from this face, because I have the B-axis on a main spindle, and during the last session I'm going to use B-axis on the back spindle too, by the way. What is interesting here is that I'm gonna divide my first part of the programming process on 2 parts, as it should be for the Swiss type parts. As you know, on a Swiss type machines, Z1 axis, it performed with part movement in guide bush device, and cutting process should be planned with consideration of allowed Z retract distance. There is a limitation of allowed part length retraction because of Swiss type machine construction. This length depends on guide bush collet. And the first part I'm gonna turn and mill will be only this part. And I will cut the first part and then continue till about that coordinate. This is going to be my workflow today. During the cutting of the second piece, the part should not retract back completely to the collet. This is the condition which we should support on the Swiss type machines. So I should be careful with my Z1 retraction to the collet. And today I will show how we can program this inside SolidCAM. Then I'm gonna program the cutoff process, part transfer, and I will program all these elements on a back spindle. Okay, let's start from the CAM part creation. And before I'll go to my new CAM part, I would like to pay your attention on SolidCAM settings, which we which is recommended to use for some mill turn machines and especially for Swiss type machines. The first is about automatic CAM part definition. If we go to the mill turn tab, it is recommended to have these tips on, create machine setup and create coordinate system for each station and opposite side of CAM part for subspindle. That means that you will get your Mach 2 position for the back spindle automatically. The system will take the right coordinate system, the direction of the axis from the VMID machine ID file. So we recommend to have it. Define fixture and clamp can be disabled because most of the Swiss type machines doesn't use special fixtures, only collets and spindles. So it's normal. If you have some additional things there, for example, the longer noise of the collet, which is clamped, for example, on the back spindle, you can use it. But today I'm not going to use it and I will disable it. The second set of the parameters is about machine simulation. We recommend on the collision control tab to put interpolation on and to have it for the nice simulation. Okay, I have these parameters on and I can create a new mill turn project. This is our standard menus. I will just apply them. Now I can choose my machine for today. It's Citizen L32 M12 configuration. We will talk about machine configuration a little bit later. The first step is to organize my coordinate system. I'm going to use the revolution face, center of revolution face as always for the Milton projects. So here I have my coordinate system for the main spindle. Because of the automatic SolidCAM settings, I will get Mach 2 coordinate system with the right direction for the current machine ID file. And I will just apply this to get my coordinate system for the back face. So here they are. And let me stop for a second and go back to presentation and to add some comments about the coordinate systems. Different machines has a different Z1 and Z2 orientation. I mean orientation on a machine. But as a part of post-processor standardization, SolidCAM recommends to apply a mirrored coordinate systems for two spindle machines. It will help to transfer CAM project from one machine to another. I will show some examples of this process later during the third webinar. And it helps to apply standard views and programming techniques for all the parts. The real z-axis signs will be outputted depends on the post-processor, and it will satisfy machine demands, and you will get good code for your machine. So now we're going to use the mirrored coordinate system for main and for back spindle and for the current project too. Let me go back to my project and check my stock. I have some default parameters for the stock. So I will have a 0.5 millimeter on the main for the main spindle for the facing operation on the main. I have 2 millimeters on my back face, and I'm gonna add 1 millimeter to the outer diameter of the stock, and I will apply that. Nice. I have my target already checked with the system. It is my my part which I loaded from which I started. So this is all came from the settings, default settings. Now I will apply my project. And now it is time to add tools. I would like to start from the tool table, and I prefer to create a tool table before I will go to the CAM tree. So here we have the empty tool table, and I'm going to start from the cutoff tool. This is one of the most important tools for Swiss type machine. All processes are starts on the first channel are starts and ends with these tools, and the position and dimensions of this tool and tool insert are really critical for the machine. So I will choose a turning tool, and I'm going to use external grooving tool, and here I can use my mounting window. So I have a possibility to check the position, dimensions of the tool, and how it will influence on the other operations. So what else I have here? Here I have a list of my tool positions. The machine is divided on the blocks, as I mentioned at the very beginning. I have a turning block where I will position all my OD turning tools. I have my radial milling tools here, and lately I will add tools there. I have my B-axis divided on the tools for the main spindle, tools for the back spindle. This is my back spindle. It is considered with machine like a separate tool. Also, I have my drilling tools. It's tools on the back spindle side. I have them here, 3 tools. And tools on for the back spindle with Y2 axis. So let me add a cutoff tool. It will have 2 millimeter insert, and I would like to change my shank because here I have it is 25 millimeter, but actual size which is applied to this machine is 16 millimeter. So I will change that. I will change a dimension and thickness, and also I would like to make it shorter. I would like to have it like 100 millimeter length. And what else I can do here? As you can see, it is positioned somewhere, but not in the tool holder, and here I have my tooltip position. On such type of turrets, I mean OD turning tools, there are a recommendation from the machine supplier, which you can find inside your programming manual, and there are information about where is your tooltip should be, and we support that and put the dimensions like 0 here to have my tooltip where it should be on the machine. The only thing it should be changed here is the position of the cutoff tool. I would like to have it reversed. I would like to do it like this. So I would like to have my insert further from the 0 position on the machine. Because I reversed it, I should change the tooltip position on the dimension of my holder thickness. Now it looks good, position good, and I will just save it and go to the next important tool. It's OD turning tool. I will add external turning tool, and I would like to have it on a third station, not so close to my cutoff tool. I have possibility to do this. I'll do this, and I will change the number to 3. I would like to use 55-degree insert. It is quite common for the turning tools on Swiss type machines. The 55-degree inserts. And then I should change my shank dimensions again. I will choose 16mm shank. And also I will change these dimensions because commonly these tools has the same thickness for this lower part and the shank. This is the normal for Swiss type tools. There are special tools catalogs also for these tools. And now I can use my 0 position for the tooltip. And also I would like to make it a little bit shorter. I don't like to have it so long. Okay, now it is time to add a milling tools. As I will have a facing operations first. I would like to add my milling tools and drills for the B station. I will add the first milling tool will be end mill. And here by default it is put to the turning position, but I will change it. And I will put it to 11 position and change my tool number. Also, I would like to have it like 4mm diameter, and I would like to change the tool length, H length. It will be like 30mm, for example. So here I can use it. The next tool will be a drilling tool. It will be 3, and by default it will take the position in the same tool table, in the same tool block, but I would like to have it in a certain position. We'll change that, and it will be 3mm drilling tool. I will use it both for facing and incline drilling today. And I will use a little bit longer distance. I will use 40mm for the lens out of the holder. Nice. And the last tool in this block will be milling tool 2, and I will use just a copy of my 4mm tool. I will put it is put it automatically to 12 position. I will change my number to 12, and I will use 6mm diameter here, and the H length is okay for me. Now I'm gonna add my radial tools, and here I will need special tool holders. First of all, I can make a copy of this tool and just change the tool position. I would like to have it on a 7th position. I will change the number, and now I'm gonna apply my tool holder. Here I have the STL database. It is very easy to add the tool holders. For example, you can download them from eSCAR catalog or whatever you want, and save it as STL and apply on whatever machine you like. So I have a catalog for Citizen machine, and I would like to show you a little trick. Here I have the tool holder, which is not mounted as I would like to, but here I have the flip around buttons, so I can organize this holder for example, several stations, if it is fitted for that stations. So now I'm gonna rotate it. I will rotate it around y-axis and around x-axis. And this is how I can get it. Or you can save it with the correct x and y direction to get a result. Okay, this is my milling tool. Also, in this station, I will have drilling and one more milling tool. I will add it as a new drill. It will be 5mm drill. And again, I need my holder, but now I have this holder in a local database. I have it here, and it is mounted properly for the current project. The one thing I should do is I should change my outside holder length to make it shorter. It is too long. And now I will add the last tool. It will be milling tool again. I will just copy my 6mm tool and make it diameter less. That's all. The other tools for the back spindle I will add during the next webinar. Nice. I will save my tool table, and next step is machine setup dialog window. Before I will open it, this window, I would like to remind you information about machine data. Machine data is a specific feature of Swiss type machines. It is essential information for controller. You can't run machine without inputting this data. Let me go back to my presentation and give you an example of machine data, what is called machine data. You can see a CNC controller of each Swiss type machine has a specific interface where user should input machine data. You can see on a screen, it's a screenshot from the Citizen controller with Mitsubishi with the list of the parameters. Currently, it is in German, but you can. I will explain more about these parameters. At the left side of the slide, you can see Citizen screen 2 as a previous one, but this one from the machine with older model. This machine is with FANUC, and on the right side you can see a description of all these parameters inside G-code. That means if you load NC file to your controller from computer, from PC, and do not create it directly on machine, you have to add this information after the command G code, which is describing operations, the cutting process. After you load NC file to controller, you will see the list of machine data with certain values, or you will see an error message if something were missed in this data. Each machine needs its own set of parameters. I would like to consider the current list of parameters, and then I will show you how to program these parameters inside SolidCAM. Let's start from the first parameter. It's material OD. one of the most simple. It is the bar diameter, and it is outputted automatically from stock dialog box. Position PT, the next parameter, is like the safe distance for in X direction for cutoff operation. It is outputted from machine options list. The next variable is one of the most important. It is called machining length. We have to review Swiss type machine construction to clarify how to get this value. The main spindle of Swiss type machine roughly can be described as consist of three parts. It's guide bush, which is guiding and supporting the bar, a clamping system, and a unit for Z1 linear movement. On the left side of the slide, you can see two positions of clamping system. The upper is a start position without machining length value. You can see that in this position, unit can't push the bar towards tool because of guide bush. We need to put it to the position showing on the lower picture. To do this, we have to unclamp the bar and then move spindle from guide bush to out from guide bush and then clamp it. The distance of movement is called machining length. And for the most cases, machining length is the maximum Z1 position of a part pulled out from the guide bush during the all cutting process. And you should know this position before you run your machine. We can calculate this position roughly. For this, we should summarize the part length, back face allowance, cutoff tool position, and add some safety distance. Cutoff tool position is critical in this formula. As you can see on the screen, it is not included for the right hand tool, and it should be added for the left hand tool. Also, you should consider offset point of the tool insert. So here you can see how cutoff tool position affects on a stock position. This is why I flipped my cutoff tool for the current project just to show you the difference in machining length. So on the left side, you can see that the distance between the 0 point and part face is less than on the right side, because here I have to care about the thickness of the tool holder, about my cutoff tool. Now let me show you one more set of machining data and the program start for Swiss type machine. On the right side of this slide, you can see a special start cycle for machine with FANUC. It is not Citizen, and Z40 here is a machining length. And on the left side, I put a short video of what is happening on the machine during this cycle. It is not operation, it is just machining data. Please pay your attention and you will see a movement of the main spindle clamping system. Here it is. So this is what we call machine length. I will repeat it again. This is movement. That's what we need to program the part, and we need to understand this length before we will run the machine and before we will add operations to the CAM tree. Okay, I hope machine length parameter is clear now, and I can explain how to input it inside the SolidCAM. We are using a machine setup window. So before you will add your first operation to CAM tree, please open a machine setup window, and for stock position and main spindle, add machining length for the axis. I'll do this later for my project, but now I should finish with other machining data parameters. I would like to finish with them. Next set of parameters here will describe the cutoff process. Cutoff tool number, the first parameter in this set, Machine should know what tool will be used for cutoff operation in advance before you will run your machine. Also, it needs information about cutoff speed and feed. Some machine models will use these values from machine data, even if you will enter these values inside your NC code. So these parameters may be more important for machine than your G code. Cutoff end, this one. Is cutoff tool coordinate in X direction at the end of the cutoff process. And machine gang unit will stay in this position waiting for next run. So this position will be beginning of the program for the next run of this cycle. We do not use retract in X direction after cutoff for most of the machines. SolidCAM will take this data from MCO cycle, cutoff operation, and machine options. Next two parameters are turning us back to machine setup window. Back work extra length is a distance between target back face and back spindle face, and the chuck extra length is a back face allowance. So machine will takes these parameters will takes from the position of the part inside the back spindle. Next set of the parameters connected with machine configuration. As I said, all machines has its own configurations, the number of attached blocks, and all tool blocks has a certain names and numbers for the machine, and one machine can has a variety of tool blocks. You can buy a machine with one configuration and then add a new blocks and improve machine capabilities. And you should give this information to controller. What tool blocks will be used now for the current machine run? This is example of the Citizen L32 configuration, one of the examples. There are a book about what attachments can be added there on a model. And there are various tool blocks that can be attached and de-attached also. So milling blocks, turning blocks, and there are stations for them. Here you can see an example of machine options list in SolidCAM dialog window for different machines on the left side. Okay, now I will go back to my CAM part and add data to machine setup window and machine options. I will go back to my CAM part. And here I have my machine options list. I will use flyout window. And here I have these parameters. Safety distance, as I said previously, I will leave the default 2 millimeters, for example. Cutoff tool number, yes, this will be the first tool. Cutoff spin, I would like it to have it like 2000, for example. Cutoff feet, 0.5. Cutoff end position, I prefer -2 millimeters. This is the number of the cycles which I would like to get. This information will be outputted to my machine data. And if I'm gonna use a special macros, not for this project. Okay, I will apply that. I will go, now I can go to machine setup window, and I know that I would like to see my part, would like to see my main spindle here. I know that my part is 45 millimeters long and my tool has 16 millimeters holder. And also I would like to leave the back face allowance and some safety distance. So I will enter 70 millimeters here. And I will use my Mach 1 coordinate system for the main spindle. This will be my machine length, which will be outputted to the program, to the G code, and it will be input to the machine interface automatically for Citizen machine. And I will use in the same setup window, I should plan my transfer values and transfer process right now for the back spindle. And I will go to the back spindle position, and I will go to stock in just for this operation, just to see my figures. And I would like to have it, I will use Mach 2 position, and I would like to have certain millimeters out of the back spindle. And these figures will be used also for the part transfer. Machine will knows where it should clamps on a part if, and it will repeat this clamping position. Of course, I can change it. And I should not forget to put my stock again to the main spindle, and I can apply this window. Now I'm ready to add operations to COM3. And as always, the first operation will be facing operation. Then I'm gonna use my OD toning, and then I will add my milling operations. So I will start as usually from the toning. If you would like it, you can start from face operation. I prefer to apply toning operation. It is recommended to use the taking geometry from the solid. It is good because if you will change your part, you will have the better synchronization with the part geometry. First of all, I would like to add the name for the operation to have a nice name inside the tree. And I will use solid and check the new geometry. Okay, I would like to have it with this face, and I can see it here. It is okay, but I will need to little modifications. I will modify this geometry as always, and for this one. So this will be my face. I will use my OD toning tool number 3, 55 degrees insert. And I will leave the safety distance for this set of operations. I will leave the safety distance. That means that my stock will goes back to the collet on 2 millimeters. I should remember about the distance, allowed distance for the part, which can be applied inside the collet. Okay, and I will leave these links. I will just copy that operation, and now I can apply the OD toning operation. I will change my geometry. I will choose this one, and it's okay for me. And also I would like to add modifications, because I will need to start from the Z0. So I will extend my stock on that direction. And it starts from the face. It's not starts from the stock. It is nice. I will apply the same tool, the same levels, and on the technology page, I prefer to apply the roughing operation. I will apply 2 millimeter step and will leave some allowance for the finish operation. But I would like to do this finishing with the same tool. Okay, and now I will apply the link. I can start from the, because I will use the same tool, I will start from the optimal from the previous, and after I will perform my turning operation, I would like to start my milling operation, and I can leave my stock out from the collet, or I can put it back to the collet. For example, I would like to leave it and to make my retract only in X direction. Okay, I will calculate it. And now I'm gonna apply the milling operations on a face. I will use the open pocket, and then I will perform the drilling operations on a face. And here I can see what tool block is responsible for that operations. It is very convenient. I will apply milling and I will apply pocket. I will call this face mill operation. I will use the same coordinate system, and I will choose my geometry for the pocket. I will use a smart face function. With this function, I have a possibility to choose both chains in one click. One of the chains should be open. It will be the first chain. I will mark chain as open. Now I will apply my tool. I will choose the tool on a B station. It will be 11 tool. This is it, the tool on the B station. And now I should choose my levels, the upper level, the lower level, as always on a milling, for the milling operations. The same interface. I will choose my overlap distance, and I will leave it as a finish several cuts, but on a zero face for this pocket. Okay, I will just check if I have approach from outside. And I would like to apply my motion control. I can do this for the face operations, and I will choose the polar type of the coordinates for the Milton machines. And Milton, you have settings inside your machine ID file. You can apply different types of output for the facing operations, X, Y, polar, and Cartesian. This will be the different modes for the machine itself, different types of coordinates, and we can support it in one operation, one interface. You don't need to create some other operation just to click on a motion control page. Now I would like to perform a face drilling operation. I will apply it as a milling, and I will choose my drilling. I will use the same coordinate system, and I just click on my face, and I will get the coordinates, the center coordinates for the holes. I will apply the 3mm diameter tool in the same station as for the previous tool. It will be here, my drill. Also, I will use it for inclined holes. And what I need to do is to choose my levels, drilling depths. I will choose it according to the tooltip. In the technology, I will leave one step cycle, G81. If your machine is not support this cycle, some Milton machines supports only PEC drill like G83, G87. The post will output it without cycle, and you will have G0 and G1 movement, the simple ISO code without cycles output. And I will leave my motion control with, I would like to have the output with y-axis, but I can apply polar. So the part will move in z-axis and tool will not move in y-axis. So I will calculate that. And now I'm going to create the cuts, inclined cuts. I will cut these 3 faces with copying through the 4-axis, and then I will add the drilling operations here. So for this operation, I will need to create an additional coordinate system so SolidCAM knows how to position the B-axis. I will add it as a profile operation. I will give the name to this operation, and I need another coordinate system. I will add one more coordinate system to the main spindle to Mark 1. It will be 1, 2, and we have a special command here. So I will just pick my face, and system knows where will be my z-axis. I don't need the drawing. I don't need to make additional calculations or additional coordinate system in SolidWorks. I just click on a face. So these figures will tell SolidCAM how to lead in how tool should lead in the levels of lead in, tool start, tool Z level, and I can go back and change these figures after I will create my toolpath, because when I create it, I will understand the coordinates of the tools. If I do not like them, I can change these figures. I can go back and change them. I can change them from here or from here. Okay, I have my coordinate system. Now I would like to add a new geometry. I choose the profile, so I will pick just one line here. And I will apply a 6mm diameter tool in the same B-axis block as for the previous tools. It will be 12 millimeter diameter tool, 12 position, 12 station. So now I will choose my levels. I will have my upper level at the cutted surface from which I have after my turning operation, and I will have my depth of cut. And also I would like to change the position of the tool. If I go to geometry inside technology page, I can see that I should shift a little bit the position of the geometry. I can do this separately in offset part of this dialog box. So I will apply it like, for example, -5. And this will be my cut. This is how my tool will be positioned during the cutting. Now I will leave just finish one cut, and I can apply a tangential lead in and lead out to make it more safety. Okay, this is my toolpath, and now I would like to copy that for the two elements which I have here, and I will use the transformation button. Here I have the 4-axis transformation, and I will leave the original operation. I will apply the angle, and there will be 2 steps. Here I have before, I will click OK and apply. I can see the positions of the new elements. So I will apply them and save. And here I have my my toolpath. Also, I can see the distance, retract distances. This distance and this radius will depend on the parameters of coordinate system, which I showed previously. Okay, now let's go further, and I will apply inclined drilling. Here I will use the same Mach 1 to coordinate system. So I'll go to milling operation again, go to drilling, and I will name this operation like inclined drill, and I will choose just one hole, and then I will use transformation again. So this is, I will just pick the surface, and the system found the center position of the hole. Here I will use the same tool as for these holes. It's a 3mm drill. It is here. And I should take care about my levels. The lower level. And what I want to do, I will leave just one step cycle again. I will apply the back cycle lately for the radial holes. That's all. I have my drilling operation, and I will use transformation again, the same way, the same angle. Now I have my inclined drilling. After that, so I finished with the first part. This is the elements on the turned surfaces. Now I need to perform one more turning operation, and then I can take care about these radial elements. So I will stop for a second and check my elements. I will apply simulation. For example, solid verify first. And then I would like to see my machine simulation. Okay. I will click on a move list. You can see the list of my operations. You can see all my tools. This is the beginning from the setup, my machining lens. And now I can check the simulation run a little bit faster. So I have my facing operation, my OD turning, just the first part. Then I have my polar milling, drilling, and my inclined milling and drilling. Okay, let's go further. I will back again to my part, and I'm ready to add one more turning operation. I will use turning. We'll name it as MS OD turning 2. Again, I will use geometry creation on a solid. And I would like to choose this face. I will check the direction. It's okay for me. And what I'm gonna do, I'm gonna add some geometry modification because I would like to a little bit more here and here. So I will add just 1 millimeter tangential extension at the beginning and in the end. Okay. Now I will go to my tool. It will be tool number 3 again, for which I used for OD turning. And now what I'm going to show you is the special thing for the mill turn machines, which we have inside the software. It is called brake material corner on stock. I will calculate my toolpath without this parameter and with this. I will leave it blank now, disabled, calculate the toolpath, and will show you what that means. So first of all, I will apply the rough operation, but I will leave it, leave the offset as a 0, and I will not gonna use finish operation here. And the very important thing is I don't want to retract my part back to the collet. I would like to leave it so this part will be out from the collet. It will not go back. Only this part will move. So I will put the safety distance here for the x-axis, and I will calculate this toolpath. What I'm going to show is the this part. So if we will we will leave the stock as it is, and when I'm gonna, for example, mill this part, mill this pocket, the part should go back to the collet. And for some materials, for example, like stainless steels, we can have some burr here, so additional chips which weren't cut and which is still on a stock. And to get rid of this additional material which can damage my collet because of the hard material, it can damage when the part is retracting back to the collet. We have a special option. It's the brake material corner on the stock. So I will apply this this option. I would like to have half a millimeter size chamfer, and I will calculate that. So I will have an additional movement of the tool to break the material and to not have an additional material here because of the part retracting. Okay, I have this face cut it, and I would like now to cut this radial element. So I will use I will need one more coordinate system, and I will use the profile again. So it's a simple 2D milling operation. The difference is that I will need one more coordinate system. I will edit, and I will choose the same way, the same parameter, just pick on a face, and I will get the proper direction for the z-axis. Okay, I will leave my coordinates at there, and I will name my operation like radial milling, and we'll add a new geometry here. So here I will need two chains. I will use tangent propagation. I will choose the first piece. I'm sorry. This will be my first chain, and I should have the second chain, but with the opposite direction. Okay. And now I can choose my tool. It will be radial tool, 10 millimeters diameter. I will show you it. So this is it, my radial tool. I will choose it. And now I will choose my levels. The cutted level will be upper, and the level of the face. Okay. On the technology page, I should check the direction of the tool. And let me check tool again. Oh, it's 6 millimeter. I need 10. Okay. Okay, I need 10 millimeter diameter tool. Okay. Now it looks better. I will leave just one finish cut, and what I will need also is the links. I will make it as a tangent, and I can calculate. What else I need to get rid of this extra retracts. I would like to join this piece of cuts together with just one line. For this purpose, I will use separate areas through, and I will use the level of current toolpath option. And now I have a good toolpath with Y direction. Now I can add my drilling operation. So I will add drilling with the same z-axis direction, the same Mach 3, 1, 3. I will just pick the face, and I will get the coordinates of my holes. I will use a drilling tool. It will be 5 millimeter diameter. Okay. And here I will use levels, and I would like to use the pack cycle. I'm going to technology. I will use pack cycle. We will have for this machine ID, there will be the one pack cycle, both for facing and for radial elements. And I will apply the step as a 2 millimeter. Okay, I will calculate that. So I have my holes, and the last operation for today is the pocket, wrapped pocket operation. So I will go to milling operations. I will go to pocket, and I should apply because it is wrapped, I should clarify for the system what axis will be the axis for the wrapping. It is z-axis, and I will use Mach 1 coordinate system, and I should, in the geometry edit window, I should use a wrapped type of the geometry. I should use the wrapping axis, and also I will add a chain by clicking on a face. So I have my chain closed, and I will apply that. And here I'm going to use a small 4mm diameter tool. Let me check it. Yes, it's tool number 9, sorry, tool number 9. And here I will apply levels information. I will need as a upper level my diameter, and as a pocket depth the depth of the face. It's just 1.5 millimeter depth, and also I will apply the 80 percent of the tool diameter overlap for the tool. It will have the only finish cuts, and for the link I can apply vertical, angular. For example, I will apply an angular movement and with 3 degrees angle. And if I go to the motion control, because my geometry were wrapped, system automatically found the axis and the type of the coordinates to output it on the machine. So I will apply that, and I will have my toolpath. Now I can go to simulation and check what I will have before I'll go to the cutoff operation. I will check it for the solid verify. And go to machine simulation. It is not should load, not should takes a lot of time to load. It happens because of online translation. The time of loading depends also on a value of the STL files. We're trying to make them as less as possible. So we will repeat a little bit what we had previously. Turning operations, some milling, very fast, sorry. Okay. And the new turning. And my milling operations. So this is the what we will have. We will start from this moment during the next webinar. During the next webinar, I will show how to perform the cutoff operation and transfer for the Swiss type machines. We will review the MCO operations, MCO cycles for this process, and we will finish with this part on the back spindle. Thank you for your attention now. And hope you will join to our next webinar, next session during this webinar.
Okay,
Sydney,
Marina,
are you there?
Yes, I am, of course. Thank you very much. There are some questions, but what we'll do is I'll send you all the questions that we have here from the webinar, and each one you can answer them individually by email. This webinar has gone a little over the actual expected time, so she'll send the emails to all the questions that are asked to over here. All right, again, thank you very much. Again, this has been recorded and will be available later on. Take care, everyone, and have a great day. Bye-bye.